equations with linear coefficients. So let's solve x plus y plus 1 dx plus x minus y dy equals 0. So the idea of these equations is to use some substitution where x is going to be u plus k and y equals v plus h, where k and h are constants and u and v are my new variables. So the differentials are dx equals du, because don't forget k, it's a constant, so differentiated with respect to x is 0, and dy equals dv. So now, when we replace this into equation star, we get u plus k plus v plus h plus 1 du plus u plus k minus v minus h dy equals 0. The condition that we are going to apply to this constant is that k plus h plus 1 equals 0, k plus h plus 1 equals 0, and k minus h equals 0 as well. K minus h equals 0. I want them to be 0 so that they disappear from our differential equation and we obtain an homogeneous one. So how do we solve this? Well, we can add them together and we get 2k equals negative 1, k equals negative a half, and h equals k from the second one, so it's negative a half, which means that x equals u minus a half and y equals v minus a half, which we'll need them when we go back to our substitution. So now, if we replace h with k in 2 stars in this equation here, we are going to get u plus v du plus u minus v dy equals 0. So, oh sorry, not dy, dv equals 0. So now, I'm trying to write a little bit darker. So now dv du, because since x was my independent variable, u is going to be now my independent and y is the dependent and v is. So now dv du is going to be u minus v at the bottom and at the top u plus v. But keep in mind, if I get u minus v dv on one side, I'm going to get minus u plus v du on the other side. So there is a minus, which I can put in front of the fraction, or I can write it at the denominator like this. So now, I want, this one looks like it's a homogeneous equation. So I want to use v over u to use some substitution, which is going to be easy. So in order to do that, I'm going to divide by u the top and by u the bottom. So that's mathematically correct. It's like I divided by 1. So I get 1 plus v over u equals v over u minus 1. I switch their order as well. So dv, or maybe I should leave it aside for a little bit. I'm going to get z plus 1 over z minus 1 if I use this substitution. But of course, I don't want to have dv du anymore. So what we're going to do is v equals u times z. Again, v is a function of u, z is a function of u, and u is the independent variable. So dv du equals u prime times z, so that's z, plus u times dz du. So this is important because I'm going to replace it exactly here. So u dz du plus z. So when I differentiated this as product rule. So u dz du equals z plus 1 over z minus 1 minus z. So I'm going to multiply by z minus 1 and get u dz du equals z plus 1 minus z squared plus z over z minus 1, or u dz du equals negative z squared plus 2z plus 1 over z minus 1. This looks like a separable equation. So z minus 1 over negative z squared plus 2z plus 1 dz equals du over u. So we are ready to integrate. Now the bottom part, if we do, I'm going to avoid using one more substitution, but if we look at this denominator, if we differentiate it, we get negative 2z plus 2. So basically I can multiply the top by negative 2 and then eliminate that negative 2 because I cannot just multiply something. I have to multiply by 1 basically. So this one becomes negative a half, and then at the numerator I have negative 2z plus 2 dz, which is exactly the derivative of the denominator, which makes it natural log of negative z squared plus 2z plus 1 equals natural ln of absolute value of u plus c. So now I'm just going to solve for z. So I multiply by negative 2. So ln of negative z squared plus 2z plus 1 equals negative 2 ln. So I can actually say ln of 1 over u squared plus c. And I'm going to raise e to each of them. So it's going to be negative z squared plus 2z plus 1 equals c times 1 over u squared. Let's not forget z was v over u. So I'm going to go back and say v squared over u squared plus 2 times v over u plus 1 equals c times 1 over u squared. And also x was u plus k, but we already calculated that, and y equals v minus plus h, but was negative 2. So I'm going to replace. So I get, instead of u we put x plus a half, instead of v we put y plus a half. So here we're going to have minus y plus a half over x plus a half, everything squared, plus 2 times x plus a half over, y plus a half over x plus a half plus 1 equals c over, well, u squared is x plus a half squared. And of course, this is pretty messy, so we can bring everything to the same denominator. So it's going to be minus 2y plus 1 over 2x plus 1 squared. I can square each of them. Plus 2 times 2y plus 1 over 2x plus 1. If you're wondering where did they go, the denominator is as if you multiply by 2 top and bottom. And when you do that, it's like multiplying by 1. Plus 1 equals, and here I cannot just multiply by 2, so I can actually say 4c over x, 2x plus 1 squared. So this one, I kind of did it mentally. It would be c over 2x plus 1 over 2 squared. So it's c over 2x plus 1 squared over 4. So the 4 comes up, and yeah, you can actually say instead of 4, just c. And can I get it in a nicer form? Yeah, I can go further and multiply everything by 2x plus 1 squared. So you get negative 2y plus 1 squared plus 2 times 2y plus 1 times 2x plus 1 plus 2x plus 1 squared equals just c. So I think this is nicer because we wrote it in an implicit form, equals c. I hope it helps.